Bismillahirrahmanirrahim. In this video lesson, we are going to learn about derived functions, which is a new addition in Cambridge's IGCSE 0580 for examination 2020 onwards. By the end of this video, you should be able to understand what are derived functions and how to find derivatives of simple functions and their respective sums and differences for maximum up to 3 terms. I will explain this bit later on. Applications of derivatives. I have split them into two. The first one is finding gradients of curves at given points, and the second one is finding points on curves for specific gradients. Before I move on, let me take you to the clipping taken from CAIE published syllabus for 2020 examinations onwards. In the section E2.13, you should be able to see, understand the idea of a derived function, use the derivative of functions of the form ax to the power n, and simple sums of not more than 3 of these. In this video, we shall be covering these two objectives. In the second video, we shall be doing these two applications as well, which are application like in applying differentiation to find gradients and turning points, and discriminate between maxima and minima by any of the methods. Now, first of all, let's just see what do we actually mean by derived function here. If you're a sciences student, you must have seen something like this: delta x over delta y, and you must have read delta as change in x over change in something. If you're not a science student, then let's just talk about mathematics. Let me just draw a first quadrant of a Cartesian plane. Let's just assume I have 2 points A and another point B here. Let's just say the x-coordinate of point A is x1 and the x-coordinate of point B is x2. Similarly, the y coordinates of the respective points as y1 and y2 respectively. Now, if I am to go from A to B, when I will be doing a vertical movement, I'll be covering this distance. Now, this distance can be given as y2 minus y1, which can also be referred as a vertical change. So which is y2 minus y1. And then from here, I will be doing a horizontal movement. And in order to determine this distance, it's a horizontal change, and that can be given as x2 minus x1. And if you can recall from the coordinate geometry, the vertical change, which is y2 minus y1, over the horizontal change, which is x2 minus x1, was basically giving us the gradients, the gradient of a line joining A and B. So basically, y2 minus y1, the vertical change is rise, and x2 minus x1, the horizontal change is run. And if I replace these two, instead of using delta, I can say I'm going to use the letter D, and instead of using rise or saying y2 minus y1, I can write this down as dy as change in y, which is rise, or y2 minus y1, over change in x, so which I'm going to read as dy by dx. So basically dy by dx is the gradient, and this is called, whenever for any equation, dy by dx is going to be the derived equation, or you can also call that equation as equation of gradient. Now, how do we actually find the gradient's equation or the derived equation? Now, if you refer back here, simple functions, and from the Cambridge clipping, use the derivatives of functions of the form ax to the power n. Now, this is how I'm going to do. For example, I have an equation y equals ax to the power n. I'm going to apply a derivatives operator, which is d by dx, on either sides, on both of the sides. On the left hand side, I'm going to get dy over dx. On the right hand side, you will have to remember this rule for good. N, which is the power of x, will come back here and will be multiplied with the coefficient, which in this case is a. So I'm going to get n a, and then the power of x, whatever it is, will be reduced by 1. So in this case, I'm going to get n minus 1. So you have to memorize this rule. Let me just quickly take you through the rule again. Y equals ax to the power n is the simple equation, and this is how I'm going to find the derivative. So dy by dx means the derivative has been taken, and then the n is going to be multiplied with the a, and the power of x will be reduced by 1. So this is what you are going to do all the time. Along with this general rule, let me give you some supporting formulas, or you can say the special cases or the facts. Whenever you have y equals just the x, means the coefficient of x is 1 and the power of x is also 1, the derivative is always going to be equal to 1. And whenever you have y equals ax, the derivative is always going to be equal to just the a, means just the coefficient of x, and a can be any rational constant. It can be positive, it can be negative. You can associate these two special cases with this general rule up here. The third special case, whenever you have y equals any constant number, remember the derivative of any constant number is always 0. Now, if you look into the graphical perspective of this equation, and if you can recall from graphs of linear equations, whenever you have the equation y equals to any constant number, that gives you a horizontal line, and the gradient for a horizontal line is always 0. So in this manner you can connect these two. The derivative means the gradient of this equation is going to be 0, because y equals to constant number is going to result in a horizontal line. Now I'll leave here for a moment so that you can have a quick glance. Okay, now let's just move to the practice section and solve a few of the questions. Now, for example, let's just pick a question from here. For example, let's just do part E. Now, the question is y equals 12x squared. Now, dy by dx is going to be, by applying the general rule, let me put that rule down here. So for y equals to ax to the power n, dy by dx is always going to be equals to n ax to the power n minus 1. Now in this case the power of x is 2, which will come back here and will be multiplied with 12. So 12 times 2 is 24, and the power of x will be reduced by 1. So I have a power of 2, and it will, after reducing by 1, I will have a power of 1, which there is no need to write. So this is the derived function, or the derivative of y equals 12x squared. Now let's just try another question. Let's just do part G. Now it says y equals 4 to the power 4. Now when I'm going to take a derivative of this one, dy by dx, again by applying the general rule here. Now 4 times negative 4 is going to result in negative 16, and the power of x will be reduced by 1. So from 4 it will be reduced by 1. So that will give me my negative 16x cubed. So dy by dx equals negative 16x cubed. Now let's just say we have a question of this kind: y equals 4x squared minus 12x cubed plus 5x squared. Now let me take you through this again. Not more than 3 of these, and the thing which I wrote down here, maximum up to 3 terms. Now by that, this is what we meant. Like, the examiner of Cambridge is going to assess you of these kinds of equations which are not going to have more than 3 terms. So this is a question with a maximum number of terms which can come up in the examination. Now the question is y equals 4x squared minus 12x cubed plus 5x to the power 4. Now here is another, and it says simple sums, and in the learning objectives I have written down here their respective sums and differences. Now here we have 3 terms being added or subtracted. Now the key to do these kinds of question is apply the derivative on each term separately. The general rule, which was dy by dx equals ax to the power n. Now each of these term looks like this general term. Now you are going to apply, I'm sorry, this is not dy by dx, this was y, and dy by dx is going to be equals to nax to the power n minus 1. You're going to apply this general rule on each of these terms separately. So dy by dx is going to be equals to, for the first term, when I apply the general rule, it's going to be 2 times 4 is going to be 8, and then x to the power 2 will be reduced to x to the power 1 minus 12 times 3 is 36, and x cube will be reduced down to x squared plus 5 times 4, with the 4 will come back here and we'll multiply with 5, so that will give me 20, and x will be x power is going to reduce down to 3. So this is the derivative of this equation. This is how you find the derivatives. Now remember, on the internet you may find product rule and the quotient rule, which is not a part of Cambridge syllabus. But for example, if you do get a question in which you have two factors, like if I pick any of the question here, now for example part D, now it says y equals x minus 4 times x minus 5. In higher classes we have product rule for these kinds of questions, but as I stated earlier, the product rule or the quotient rule, they both are not a part of Cambridge syllabus, so you will have to apply some of the technique. Now if you focus, you can expand these two factors. Now after expanding, I'm going to get x squared minus 4x minus 5x plus 20. Now y equals x. Now after adding up the like terms, I'm going to get x squared minus 9x plus 20. Now if you look carefully, you have each of these terms are getting into the shape ax to the power n. Now I'm going to apply the derivative of each of these terms separately. So dy by dx is going to be equals to 2 times 1 is 2, and x power will be reduced down to 1, which there is no need to write down. Now if you focus, this one here is the special case. Now y equals to ax, if you refer back to the special cases you wrote down. Now this is going to be, let me write down the special case here. So y equals to ax, so dy by dx is always the a itself, the coefficient. So in this case I'm going to have minus 9. Now the third term is a constant term, again the special case, y equals to any constant number, the derivative was always equals to 0, so there is no need to write down 0. So this is the derivative for this one. Now this is how you find the derivatives. Remember, you're not going to get a negative power of x. Now refer back to the clippings from the Cambridge syllabus. Here it elaborates that ax to the power n, where a is a rational constant and n is a positive integer or 0, means clearly you're not going to get any negative value of n. But just in case if you do get, just to give you an idea how you're going to go about it, for example you get a question y equals 2 over x cube. Now for this kind of question we need a quotient rule, because x cube is in the denominator. Again, as I stated earlier, product rules and the quotient rule, they are not part of your syllabus, so I will have to think of something else. If you can call laws of indices, I can rewrite this equation as y equals 2x to the power negative 3. Now you see this is coming into the shape. Now I can easily find the derivative. So dy by dx is going to be equals to negative 3 times 2 is going to give me negative 6, and the power of x is going to be reduced by 1. So in this case I have my negative 3 as a power of x. When I reduce this by 1, I'm going to get minus 4, so x to the power minus 4. So this is the derivative of y equals 2 over x cubed. Alright, now moving on towards the applications. Now the first application is finding gradients of curves at given points. And for that, if you refer to the question number 2 here, find the gradient of each of the following curves at given points indicated. Now y equals x squared. Now let's just do this question at the point 3, 9. And the question is, y equals x squared 3, 9. Now let me just explain you first that what is the question actually. The question is to find the gradient of this curve. Now definitely this equation has a curve. Let me draw the curve for you, which you don't have to draw all the time, but just to help you understand the question. Now this is how the curve of this equation looks like. This is a quadratic equation, and this is how it is going to look like. Now let's just assume this point 3, 9 is here. This is that point. 3, x is 3 and y is 9. Now the examiner is basically asking you that on this curve, at this point, find the gradient of the curve. Earlier you've been doing these kinds of questions by drawing the tangents at this point, but now we are not supposed to draw the tangents. We're going to use derivatives, means no tangents. So we are going to use derivatives in order to find out the gradients of the curves at given points. How are we going to go about it? Definitely, first of all, we need an equation of gradient, so which is dy by dx by applying the general rule on this one. So 2 will be multiplied with the coefficient, which in this case is 1. So 2 times 1 is going to be 2, and the power of x will be reduced by 1. So 2 minus 1 is going to leave us with 1, which is, there is no need to write it down. So the gradient equation is dy by dx equals 2x. Now the question was to find the gradient, the value of the gradient, the slope on this curve at this point. Now all I'm going to do is plug in the x coordinate, which is 3, into this equation. Now this dy by dx equals 2 times 3, so this is gonna give me 6. Therefore dy by dx equals 6, means rise over run is 6, or the gradient is 6. Gradient of, definitely, y equals to x squared is 6 at x equals to 3 and y equals to 9. Remember, you're going to plug in the x coordinate of a given point. Now let's just try another question. Now I can see here, find the gradient of each curve at the point with the x coordinates. Now you don't need a y coordinate, so that is why there is no y coordinate given. But just in case the examiner gives you the complete order pair, so you're just going to pick out a x coordinate from there and plug it into the equation of the gradient. Now let's just try question number 2's part B, which is y equals negative 2x to the power 4 plus 3x squared, and we are supposed to find out the gradient of this equation at x equals minus 2. Now you don't have to draw the graph all the time. That was just to help you understand the requirement of the question. Now we will find the derivative, which is dy by dx, and the derivative, after applying the general rule on each of the two terms separately. The 4 times negative 2 is minus 8, and the power of x will be reduced by 1, which is going to leave us with a cube, plus 2 times 3 is going to give me 6, and the power of x will be reduced by 1. So this is the equation of the gradient. Okay, now I need to find out what is the gradient of this curve at x equals negative 2. Now I'm going to plug in negative 2 into the equation of the gradient. So dy by dx equals minus 8, and then negative 2 cubed plus 6 into negative 2. Now minus 8 and negative 2 cubed is going to give me negative 8, and then plus minus minus 6 times 2 is 12. This is going to give me 64, take away 12, and this should give you 52. So the gradient of the graph y equals minus 2x to the power 4 plus 3x squared at the point where x is minus 2 is 52. Now this is the first application of derivatives. This is how you use the derived function. Now another way you can use the derived function is finding points on curves for specific gradients. This is the opposite of the first application, means you will be given with the gradients and you are going to find out in your graph on which points you are going to have that specific gradient. Now for example, let me give you a question here. For example, you have a question y equals 2x cubed plus 3x squared, and I want to know where this graph is going to have a gradient of 12. Now again, definitely you need to know the equation of the gradient. So dy by dx equals to, now 3 times 2 is going to give me 6, and the power of x is going to reduce by 1, so that will leave me with 2, plus 2 times 3 is 6, and the power of x will be reduced down by 1 and will leave us with 1. So this is the equation of the gradient. Now I want to know on this curve where I am having a gradient, which I can write it down as dy by dx also. So this is basically gradient of 12. So dy by dx of this equation is 6x squared plus 6x, and I want to know where is this equals to 12. So I'm going to simply equate both. So this is going to give me 6x squared plus 6x equals 12. Now 6x squared plus 6x minus 12 equals 0. Now this is a quadratic equation. Now from here you can take 6 as common. Now x squared plus x minus 2, and at the same time divide 6 on both sides of the equation. So you have reduced and simplified it to this. Now you can solve this quadratic equation for x by any of the methods. Let's just factorize by middle term breaking. So x squared plus 2x minus x minus 2 equals 0. Now I can take x as common from the first two terms, and I will be left with x plus 2, and then the negative 1 as common from this last two terms, and I will be left with x plus 2, and then x plus 2 is common and x minus 1 is left over. Now I have two factors and they are equal to 0, so it means either x plus 2 equals to 0 or x minus 1 equals to 0. So from here I get x equals minus 2, and then from here I get x equals plus 1. So there we are. Means this equation y equals 2x cubed plus 3x squared is going to have a gradient of 12 at x equals minus 2 and x equals 1. There is no need to draw a graph, but just to help you with understand the question. Now this equation is a cubic equation, so roughly it is going to have this kind of sketch. Now it is going to have a gradient of 12 at 2.1 here, which is going to be negative 2, and 1 here, which is going to be positive 1. So this is how you are going to solve the questions. I'm going to give a link for these pictures in the description of the video so that you can download the pictures from my Google Drive and practice the questions. If you have any questions, feel free to contact or leave in the comment section. Thank you.